In section 8.2, we're going to extend the ideas that we learned in 8.1, and we're going to write them in a little bit different way. We learned that if we are after the cube root of 8, we could write that using radicals, putting a 3 out in front for the cube root, and an 8 underneath. Today, what we're going to do with our rational exponents is we're going to write it using a fraction. We know the word rational means fraction. So I can write 8 to the 1/3 power instead of using radicals and sticking a little 3 in there and writing the cube root of 8 that way. In general, if you have 8 to the 1/n power, that means the nth root of a. So the first thing we're going to do is practice going back and forth. If you're asked to find the 4th root of 16 using rational exponents, we would write 16 to the 1/4 power. If you were asked to find the cube root of x, we would write that as x to the 1/3 power. Or, if you're given y to the 1/5 power, you should understand that what we're asked to find is the 5th root of y, and we could write it using radicals that way. So if you're asked to evaluate or to simplify, or however the instructions say, they say find 9 to the 1/2 power. What that means we're trying to find is the square root of 9. And the square root of 9, the number that we square to get 9, is equal to 3. If they ask us to find 8 to the 1/3 power, what they're asking us to find is the cube root of 8. Or what number do I cube to get 8, which is 2. If they want us to find 625 to the 1/4 power, they're asking the question, what is the 4th root of 625? And the number that I take times itself 4 times to get 625 is 5. Now what we'll also encounter are questions like, what is 16 to the 3/4 power? Or what is 27 to the 2/3 power? Or what is 243 to the 3/5 power? And so we have to figure out what to do when that number on top of our fraction is no longer a 1, like it was up here on these 3 examples. So let's hop to another page and then we'll return to these examples. The first idea that we're going to look at, and it'll all tie together, so this may seem strange at first, but if I have x to the 20th, I know from my rules of exponents that we just tested over on Tuesday that if I have a power to a power, that means I multiply my exponents together. So I could write x to the 20th as x to the 4th to the 5th, because that product is equal to 20. Or I could write it as x squared to the 10th, because 2 times 10 is also 20. Or if I wanted to, I could flip-flop either of those pairs. I could switch the 5 and the 4, or I could switch the 10 and the 2. And all of these statements all are exactly the same. They're all equivalent statements, because the product of any of these pairs is 20. So if I put it together, I'd get this, or I could peel it apart using any possible product. The other idea that we're going to talk about is if I have the fraction 5/8. I can write 5/8 as the product of 5 and 1/8. 5 is just 5 over 1, so I could look at 5/8 as the product of 5 and 1/8. I could talk about 6 17ths as being the product of 6 and 1/17. So I want you to think about the products that would create 2/3 and 3/5 and 3/4. Go ahead and pause the video. Think about how to break apart each of these fractions, similar to what I did up here. And then think about how we could generalize it for the fraction m over n. So pause the video, break these guys down, and then turn it back on so you can see how you did. Two-thirds can be written as 2 times 1/3. 3/5, 3 times 1/5. 3/4 as 3 times 1/4. And in general, for any fraction that you have, you can write it as the top number times 1 over the bottom number. These two ideas, this initial idea of breaking apart a number into a product of two things, and being able to break a fraction into the product of these two things, we're going to combine those ideas together to help us figure out and evaluate things like 16 to the 3/4, 27 to the 2/3, 243 to the 3/5 power. So the first thing we're going to do here, scroll down so we have space, is we said if we can write 3/4 as the product of 3 and 1/4, I can look at 16 to the 3/4 this way, or I can look at 16 to the 3/4 this way, and then I can go from here. Now, to save space and time right now, because these videos I know can get long really fast, you could try this path on your own, and you should get the same answer that way as we will when we take this approach here. The first thing we're going to do is the parentheses, because that's what our order of exponents tells us we should do. And I know that 16 to the 1/4 power means I'm supposed to find the 4th root of 16. So the number that I take to the 4th power to get 16 is 2. And then once I've done that, I still have to come back and take that expression to the 3rd power. If I take 2 times 2 times 2, I'm going to get 8. I'm going to try to squeeze in right here. Same idea, 27 to the 2/3 power. I know 2/3 is 2 times 1/3. The shorter path, and the one that will give me smaller numbers, is always going to be to put the fraction inside the parentheses and to do that part first. So 27 to the 1/3 power is asking the question, what is the cube root of 27? And the cube root of 27 is 3. Once I've found the cube root of 27, this is telling me I need to square that number. 3 squared is 9. Go ahead and pause the video, see if you can mimic what we did on these two examples to find 243 to the 3/5 power. Three-fifths, just a couple minutes ago we decided was 3 times 1/5. And I'm going to put the 1/5 in the parentheses so I get to do that one first, and then I'll come back and take care of the 3rd power later. In section 8.1, we figured out that the 5th root of 243 is equal to 3. And so once I find the 5th root of 243, all I have to do is cube that number, and 3 cubed is 27. in general, if I have an expression to the m over n power, I can find a to the 1 over n power and then raise it to the mth. In my fraction, leave myself enough room, the top number is the exponent, just like we've always looked at exponents. That 3 meant we cubed something. The 2 meant we squared something. This 3 meant we cubed something. And then the bottom number of your fraction is always your root. I got to take the 5th root of a number, the cube root of a number, the 4th root of a number. And you can do these operations in either order. It doesn't matter, but again, it's going to make the problem shorter if you do the root first and then raise your answer to that exponent, the top number of your fraction. There will be a second part to this video, so you'll need to look for it to get the rest of section 8.2, but I don't want this one to get any longer than it is. So look for that second part of the video for the rest of the exercise help.